Hello everyone, we're here today to talk about Math 100, sections 2.1, 2.2, and 2.3. We're doing a little bit of a different strategy for this section. We're going to combine three of them into one. So this will cover three sections of the textbook rather than just one. So first, let's remind ourselves of some skills we are going to need in this section, and that is combining like terms. If I have 3x plus 6x, that should add up to be 9x, right? Because they're like terms. 5y minus 2y, well, since they're like terms, that should be 3y. In my third example, I've got an x here, which I can put a 1 in front of, right? Anytime you don't write the number, you can put a 1 in front of it. And I have a minus 8x, and then I have a 3 and a 12. So I identified my like terms, and now I'm going to use those. 1x minus 7x is going to give me negative 7x. And then positive 3 and positive 12 will be plus 15, right? So when I combine my like terms, I get negative 7x plus 15. In my last example, I have minus 3x and plus 4x. I have a 2 and a 10. And I also have a 5y and a 2y. So I delineated which terms were like, and now I'm going to combine. Negative 3x and plus 4x will give me x, right? 1x, or x, right? Negative 3 and 4, or negative 3 and plus 4, those combine to be positive 1, right? For the constants, I have 2 and 10, and they're both positive, so that'll be plus 12. And then for the y's, I have minus 5y and plus 2y. Those will combine to be minus 3y. Now, let's check another skill we want to be fresh on, and that's evaluating expressions. We want to be able to plug in and evaluate. In my first example, I'm going to rewrite the problem carefully with parentheses where the x's were, because I'm going to plug in the x. Notice, where did this 1 come from? Well, it was hiding here all along, right? There's a 1 out front of that x squared. Now, I'm going to plug in the 2. 2 and 2. The first thing we do here is exponents. So I'll have negative 1. 2 squared is 4, plus 3 times 2 plus 10. The second thing we do is multiplications. Negative 1 and 4 make negative 4. 3 and 2 make 6. And the 10 is still along for the ride. Adding together, negative 4 plus 6 is 2, and 10 more is 12. So that was our first example. In our second example, first things we're going to want to do is plug in x as negative 3 plus 4, y is 2. Once again, we start with the exponents. Negative 3 plus 4 times 4. 2 times negative 3 is negative 6, and 4 times 4 is 16. And then when we add, we get 10. So that's plugging in, right? And the reason we want to do this is because we want to work towards equations. Now, we've already talked about equations, expressions a little bit, but let's remind ourselves what an equation is. An equation is a statement of equality between two expressions. Maybe an example of that, maybe we have 3x plus 2 equals 5. That's an equation, right? Or maybe we have area equals length times width. That's also an equation, right? Now, a solution of an equation is a value that makes an equation true. It's a value that makes an equation true. That's a solution of equation. And we can check if something is a solution by plugging it in and seeing if the left side equals the right side. Let's look. We've got 15 and 3x squared, we're checking 2, plus 7 times 2 minus 11. We're checking if these are equal, right? Well, I like to put a little question mark above my equal sign when I don't know. And we just simplify each side. Good news for me, the right-hand side, I'm just going to leave it as 15. There's no simplifications needed. On the left, I'm going to do exponents first. 2 squared is 4, plus 7 times 2 minus 11. We do our exponents first. Then we do our multiplications. 12 plus 14 minus 11. And I'm still wondering if that's equal to 15. Let's see. 26 minus 11 is 15 equals 15. Yes. 2 is a solution, right? It worked out for us. 2 is a solution, right? 15 was equal to 15. After I plugged in 2, it worked out for me. So with equations, you can always check whether something's a solution. But we want to be able to solve equations. And that is what this second page, that is going to be a hefty amount of writing, is going to deal with. It's going to teach us 3 different properties we can use, and then a procedure that will solve equations for us. The first is the addition and subtraction property. And this says we can add or subtract the same value from both sides of an equation. We can add or subtract the same value from both sides of an equation. That's what that property says. That's why it's called the addition or subtraction property. The multiplication property says we can multiply all terms of an equation by the same non-zero value. We can multiply all terms of an equation by the same non-zero value. That's the multiplication property of equality. The division property says we can divide all terms of an equation by the same non-zero value. We can divide all terms of an equation by the same non-zero value. And these 3 properties, we can add or subtract, multiply, or divide both sides of an equation, will allow us to use a certain procedure. And the procedure has several steps, the first of which is clear parentheses. If your question has parentheses, your first thing you should do is get rid of them by distributing or doing the operation, by performing some sort of legal math operation that allows you to get rid of parentheses, right? Distribution, performing the calculations inside. We've seen a few different ways to clear parentheses, to get rid of them, right? Second is use the multiplication property, abbreviated mult_prop, to clear fractions. And I'm going to put a star because this won't come up a whole lot, but sometimes it will. You can use the multiplication property to clear fractions. And to do that, we consider the common denominator. And we'll see this in action. This step might seem weird, or what is he talking about? We'll see it work out. We'll see how it is used, and then we'll be able to see that it does get rid of the fractions. Step 3, combine like terms on the left and right. Sometimes you might be able to simplify things up. You can clean up the left side or clean up the right side before you start trying to move stuff around or balance the equation. And that's all we've done so far, is just doing some cleanup. We haven't tried to balance the equation and solve it yet. That's on the 4th step. The 4th step, we use the add or subtract properties to get all variable terms on one side and constants on the other. Use the add or subtract properties to get all variable terms on one side and constants on the other. Here's where we're shifting stuff around. We're using the add or subtract property. The fifth step is use the division property, I'm abbreviating it div prop, to isolate the variable. The fifth step is where you're actually creating an answer. You're actually determining what the answer is. And then the sixth step, in the sixth step, we check. You plug back in and check your answer. Check your answer. That's the sixth step, is check your answer. So we clear parentheses. We then clear fractions. We combine like terms. We add and subtract things from both sides to get all variables on one, constant on the other. Then we divide to isolate the variable. Now let's take a look at some examples. 3x minus 5 equals 28. 3x minus 5 equals 28. Now it might be handy for you to keep this list of steps on the side while you're looking at this page, because I'm going to reference it. Step 1, clear parentheses. I don't have to, right? Step 2, use the multiplication property to clear fractions. There are none. Step 3, combine like terms on the left. There are none. Combine like terms on the right. There are none. So I move to step 4. I'm trying to get all my variable terms on one side and all my constants on the other. My variables are already on the left, so I need to get rid of this minus 5 portion. I have to move it to the other side. What's the opposite of minus 5? It's plus 5. If I add 5 on this side, it will cancel out that minus 5. But if I do something to the left side, I have to do the same thing on the right side. So if I add 5 over here, I can get 3x's left here, and on the right side I have 33. Now, I have only variable terms on the left and only constant terms on the right. Now I'm ready to divide. I can divide both sides by 3 to cancel out that 3, right? I can divide that 3 out of there and leave myself with x equals 33 divided by 3 is 11. So x equals 11 is my answer. Now I should check. I like to check by either doing some mental math to justify my answers right or by using the margins. Let's look. 3x minus 5 equals 28. Let's see. 3x is 11 minus 5, 33 minus 5, 28. Yep, looks to be right. I did some little scratch work here in the margin to justify my answer is correct. Always a good idea. In our second example, we have some distributions first to take care of. I have to distribute this 2, right? I have to clear some parentheses. So I'm going to get 6t plus 11 equals 2t plus 12 minus 5. Once I distribute, right, 2t, 2 times 6 is 12. Now, I need to clear fractions. Skip that step, right? There's no fractions. On step 3, it says combine like terms on the right. Or sorry, on the left. No like terms on the left. Looking at the right, these are like terms. I'm going to combine them. 6t plus 11 equals 2t plus 12 and minus 5 is plus 7. Now I'm ready to start moving stuff around. I'm going to try and get all of my t terms on the left and all of my constants on the right. Well, to get rid of this 2t here, I need to subtract 2t. But if you do it to the right, you got to do the same thing to the left. It cancels here. 6t minus 2t gives me 4t plus 11 equals, and on the right I'm left with 7. I've got all my t's on the left. Got to get rid of this plus 11. I'll subtract 11 from both sides, which will leave me with 4t, right? Equals 7 minus 11 is negative 4. Now I've got all my t's on the left and all my constants on the right. I'm ready to divide. To get t alone, I need to divide by 4, which would give me t equals negative 1. So if I think it's my answer, I should check. once again, I'm going to do a little bit of scratch work on the left. 6 times negative 1 plus 11. Negative 6 plus 11 is 5. Yep, looks good on the left. I get 5. Let's plug in and see what happens on the right. 2, negative 1 plus 6 minus 5. Let's see, 2 times 5 minus 5, 10 minus 5 gives me 5. So when I checked, I got 5 and 5. I know my answer is correct. I can always double check my answer. In my third example, I have fractions. So I'm finally getting to see the fraction. I've got 2/3 x plus 1/3 plus, or sorry, equals 3/4. Now, I want to clear all these fractions. What I'm going to do is, in my margin, I'm going to write every number that appears in my problem. In this example, there's only fractions in the problem. But if you had a whole number, let's say there was a plus 7x here, I would write 7 here as well. You write every number that appears. Now, I look at my denominators. I have 3, 3, and 4. A common denominator between all of those would be 12. So I'm going to multiply everything by 12. The reason for this is going to turn all of these fractions into whole numbers. By multiplying by 12 over 1, which is 12, right, it'll turn these numbers into whole numbers. Remember, if you had other numbers, you'd also multiply them by 12. If there was a 7 in the equation, multiply by it 12. Here, I get 24 over 3, which divides out to 8. Here I get 12 over 3, which divides out to 4. And here I get 36 over 4, which divides out to 9, right? They all divided out to be whole numbers, 8, 4, and 9. I'm going to replace 2/3 with 8. So this will become 8x plus, I'm going to place 1/3 with 4. And I'll place 3/4 with 9. Since I multiplied every number by the same value, I use the multiplication property. I can replace them. If I solve this new equation, it gives me the answer to the old equation. So let's try it. We got x's over here and constants over here. We got to get rid of this 4, right? So we'll take away 4 from both sides and get 8x equals 5, 9 minus 4, right? To get x alone, I got to divide by 8. Going to give me x equals 5/8. So 5/8 is the answer to my equation. Notice it was much easier to solve the second equation than the first one. Now, if I want to check, I plug back into the problem with fractions. I don't plug back into the new equation. I plug back into the original problem, right? 2 times 5 gives me 10 over 24 plus 1/3. To add, I need common bases, which is 24. Multiply both by 8. Gives me 8 over 24. 10 over 24 plus 8 over 24 is 18 over 24. 18 over 24, that's 3/4 if I reduce it. So I know my answer is correct. I just checked it really quickly, right? I'm just doing scratch work to know my answer is correct. That's all we should be doing, right? We want to know our answer is correct. Now, in my fourth example, I have decimals, but that's not going to be too much of a problem because I'm still going to do the same thing. I want to get rid of my parentheses and my fractions. I already did that. Now I want to get all my x's on the left. Well, if I subtract 0.8x from this side and 0.8x from this side, they'll cancel here. 4 minus 0.8 is 3.2x, right? 4 minus 0.8 is 3.2, minus 0.48 equals, over here is 4. Got to get this 0.48 to the other side. Add 0.48, add 0.48. Gives me 3.2x equals 4.48. Now I've got the position ready to divide. I'll divide by 3.2, divide by 3.2, gives me x equals, maybe 4.48 divided by 3.2, I needed my calculator. 4.48 divided by 3.2 gives me 1.4 as my answer. So I'll circle it up because I think that's my answer. Now notice, each question required the same strategies, right? The first thing we want to do is see if there's any simplifications we can make, like clearing parentheses or combining like terms or clearing out fractions. The next thing you want to do is get all the x's on one side, or t's, whatever letter you're working with, right? And all the constants on the other. and then we divide for our answer. Always that same sequence of steps. Now down here, we have some special examples, and let's see what happens. First, there's a lot going on, right? So let's walk one step at a time. First things first here, we need to distribute 3x minus 15 plus 1x plus 12, right? This side right here, I put a 1 in there because we can. And here, 6x minus 2x, and negative 2 and 2 make negative 4, right? Minus 4. Now, on the left side, there's some like terms, right? I've got 3x and 1x. That gives me 4x. I've got minus 15 and plus 12. That gives me minus 3 when I combine them. And then on the right, I've got 6x and 2x. That gives me 4x, and I still have a minus 4. Now, I want to get all my x's on the left. So I'm going to subtract 4x from this side to cancel it out, which means I need to subtract 4x from this side. But that's going to cancel out. Weird. Well, let's see what happens. Negative 3 equals negative 4. That's false, right? This means there is no solution. This equation has no solution. The symbol we use for that is a circle with a line through it, like nope, no solution. No number you plug in will ever make this equation work out. It has no answers. It can never be solved. It has no solution. Notice this weirdness with both sides canceling out the x. That is why there is no solution. We cancel out and we're left with something false. Let's look at our other special example and then talk a little more about that. In our other special example, we need to distribute a 2 and a minus 3 first. So 2x plus 8 minus 3x plus 15 equals negative, we can put a 1x, right, plus 23. Now, combining like terms on the left, 2 minus 3 is negative 1x. Positive 8, positive 15 is plus 23. And on the right, I still got negative 1x plus 23. Now, I need to move my x's all to one side. If I want to cancel out minus 1x, that's the same as adding 1x to cancel it out, right? And over here, I'll add 1x. And once again, this weirdness of it canceling on both sides is happening, right? But this time, I'm left with 23 equals 23, which is true. This means all real numbers are solutions. All real numbers are solutions. Every number will work in this equation. Notice the same weird thing happened, that the x's canceled on both sides, but I was left with a false, negative 3 is not equal to negative 4, right? Or a true, 23 is definitely equal to 23. And that's the difference. So sometimes your variables might disappear, in which case you have no solution, or all real numbers are solutions. And the difference is whether you're left with a false or a true statement. So whenever your variables disappear, which doesn't happen a lot, but sometimes it does, you have these weird corner case scenarios. So be wary of that. Be ready for that. It can happen, right? Now, let's look at our last page and see a few more examples. And we'll solve these examples. So let's see. 2x plus 3 equals 5x minus 9. Well, the first thing I want to do is get all my x's on one side. I'm going to subtract 5x from both sides. Cancels out on the right. 2 minus 5 is negative 3x plus 3 equals negative 9. Let's see, subtracting 3 from both sides will give me negative 3x equals negative 9 minus 3 is negative 12, right? A negative minus a number makes it more negative. And then I divide by negative 3 as my last step. Gives me x equals positive 4. So I think x equals positive 4 is my answer. And then I should check it to verify that I am indeed correct. 4, let's see, 8, 11, let's see, 20 minus 9, 11. Yep, looks right. I just really quick checked in my head, right? I just plugged in 4 and made sure it worked. Now, let's move to the right. Why not? Let's go over here. Doesn't matter if we're doing them in order. Negative 2x minus 2 minus 4 equals negative 6 minus 2x. All right, I distributed. I got some like terms here. Negative 2x, let's see, minus 6 equals negative 6 minus 2x. Let's see, I want to get all my x's over here, so I'll add 2x to this side to cancel that out. Oh, but wait. If I add 2x here, that cancels that out. Left with negative 6 equals negative 6. All real numbers are solutions. All real numbers worked out, right? All real numbers are solutions. So I got to keep that in mind, that is a possibility. If the x's disappear on both sides, all real numbers are solutions. Now, how about my next example? I got decimals. Well, I got to distribute 2.1. So let's see, 3.2x plus 5.71 equals, let's see, 2.1 times 1.5 equals 3.15x plus, let's see, 2.1 times 7.3 equals, that's not right, 2.1 times 7.3 equals 15.33. Alrighty, let's see, subtract 3.15x from this side, because I want to bring it over here, right, 3.15x. Let's see, 3.2 take away 3.15 is 0.05x plus 5.71 equals 1533 on the right? Let's see, subtract 5.71, subtract 5.71. Let's see, 1533 minus 5.71 is 9.62. So I get 0.05x equals 9.62. Let's see, I got to divide both sides by 0.05x, right? I ran out of room here, so I'm not going to write it there. And I get x equals, let's see, got to divide this by 0.05. Gives me 192.4. And I should have circled this, because this is my answer, right? 192.4 is what I think my answer is. So with decimals, you might need to use the calculator more, but you'll still be doing the same thing. In my third example, I see fractions right away. So I'll write every number that shows up. 1/3, 2/5, 3, and 1/2. 1/3, 2/5, 3, and 1/2. Now, my denominators, 3, 5, and 2. What is a common denominator that would work for 3, 5, and 2? Well, 3, 5, and 2 can all be multiplied to become 30. So I'll multiply these by 30 over 1. 3 times 30, I don't need to put 30 over 1 for the 3, right? And times 30 over 1. Let's see, 30 over 3 gives me 10. Let's see, 60 over 5 gives me 12. Let's see, 90. And 30 over 2 gives me 15. 10, 12, 90, and 15 are the numbers I want now. So let's see, I'll write 10x minus 12 equals 90x plus 15. Now I keep moving the x's to the left, but we can move them to the right also. Let's see what that looks like. We'll minus 10x from both sides. Gives me negative 12 equals 90 minus 10 is 80x plus 15. Subtract 15 from both sides is going to give me negative 27 equals 80x. Divide both sides by 80 is going to give me, let's see, x equals negative 27 over 80, which I should verify that that doesn't reduce. What divides 27? Let's see, 3, 9 in itself. 3 and 9 don't divide 80, so I'm done. Negative 27 over 80 is my answer. Now, in the next one, 2x plus 3, so I got some parentheses, let's distribute first. 2x plus 6 plus 7x equals 5, distribute it, 4, distribute it, let's see, 5x minus 10 plus 4x plus 4. Let's see, I got some like terms on the left. 7 and 2, or 2x and 7x make 9x plus 6 equals, over here I've got 5x and 4x, that'll be 9x Minus 10 and plus 4 is minus 6. Let's see, I got to subtract 9x from this side to bring it over here. Ah, but that weirdness where they both cancel is happening again. I'm left with 6 equals negative 6. No solution. I can put this symbol, or I can write the words no solution. Both are fine strategies. Now, we have one example left, and it was the trickiest looking one, so we saved it till last. We have to distribute first. 1/2 times 3/4 is 3. 1 times 3 over 2 times 4 is 8x, plus 1/2 times 10 is 5, right? Minus 3 equals 4. I got some like terms here I'll clean up. Oops. 3/8 x. Let's see. Positive 5 minus 3 is plus 2 equals 4. Let's see. I've already got all the x's over here. I'll subtract 2. 3/8 x. Let's see. That cancels. 4 minus 2 is equal to 2. And so now I have 3/8 x equals 2. Now I'm going to use my trick. I'm going to use my fraction trick. I'm going to multiply all the numbers, 3/8 and 2, by the denominator. There's no need for a common denominator because there's only one denominator. That's going to give me 24 over 8, which simplifies to 3, and 16. So I get, when I plug in 3x equals 16, divide both sides by 3, gives me x equals 16/3 as my final answer. So I get x equals 16/3 as my answer. Notice I waited to use the fraction trick until I needed to. I knew how to deal with these whole numbers, so I dealt with them first. If you have whole numbers you can work with those first, right? No reason to introduce fraction math until it's necessary. And that was a myriad of examples on equations. Thank you all for joining me, and I will see you next time.